Okay, section 7.4. Okay, so as we just started, y equals 3x plus 2. We know that our slope is 3, our y-intercept is 2. So when we graph it, we have that blue line. What about the equation y equals 3x minus 2? What's m and what's b? Ethan?
M is equal to 3 and then E is equal to -2.
Right. Okay, I can't use this calculator because there's a glare, so I'll change it to this. Ah. Okay. And then when I graph it, I get this red line. What do you notice about the red line and the blue line? Yep, they're parallel. Now let's say I did a horrible job with my graphing, or I didn't graph. What tells me that it's parallel? Perfect, they have the same slope. Okay, so parallel because they have the same slopes. Okay, so nothing new, right? We learned this last week. Remember, you guys did the partner thing in class? The characteristics of lines. Alright. So what about this next one then? Y equal 2/3 x minus 1. Okay, so Dina, what's m and what's b?
M is 2/3.
Yep, and b is? Perfect. So when I graph it, again, I plot that -1, and then I do my rise over run, so which is up 2/3. I have my blue line. Right. And then the next one, y equals -3/2x plus 4. Let's see, Crochet, what's my m and what's my b?
Your m is -3/2.
Good.
Your b is +4.
Perfect. So when I graph this one, I'm going to plot the 4 at my y-intercept, and then go down 3/2. I have this line. Okay. What do you notice about the blue and the red line here? Yep. Okay. No, I like it. It's flipped. Okay. More specifically, how else can you describe it? Yeah, Melody? Perpendicular, right. It's a 90-degree angle, but 90-degree, another fancier word for it, it's perpendicular. Now, looking at the slope right here, how can you tell that they are perpendicular? Comparing the slopes? Yeah. Yep, so this is 2/3, this is -3/2, so what's the relation? It's flip and negative, right? So the fancier word that we use, negative reciprocal. Right? You will be using these words a lot in this chapter. So perpendicular because negative reciprocal slopes. Okay. Right, so instead of saying rotated 90 degrees, we can also say the lines are perpendicular. And a common mistake people do is they say this slope is 2/3, and then they say the perpendicular slope is 3/2. Remember, it's negative as well. This line has a negative slope. This line has a positive slope. So don't forget, it's not just reciprocal, but negative reciprocal. Yeah, so like another example would be if my slope is -5/6, then the perpendicular slope would be +6/5. So it's always the opposite. Okay. So right here, example 1, given y equals 3x plus 5, can you write an equation that's parallel to this line? So Ethan, this equation right here, what's my slope?
3.
And I want a parallel line to it, so I need the same slope. So give me one random equation?
Y equals 3x plus 2.
Y equals 3x plus 2. Okay, another one.
Y equals 3x plus 1.
Y equals 3x plus 1. Another one.
Y equals 3x.
Yeah, okay. Or you can even have y equals 3x plus 100. So the key is you have to have the same slope. Now think about this one. Thinking question. Can I have y equals 3x plus 5? So who says yes? I can have the same y-intercept. Y equals 3x plus 5. Who says no? I cannot have y equals 3x plus 5. All right, Kaden, why not?
Because it's just the same line.
It's just the same line, right? So y equals 3x plus 5, y equals 3x plus 5. It's just the same line. You're just drawing it on top of it. So nope, cannot have the same y-intercept. Okay, what about a line that's perpendicular to this? So if this has a slope of 3, what's the perpendicular slope? Martin. Good, okay. What's another one? Y equals, all right, y equals negative 1 over 3x plus 4. Another one? Okay. Now, can I have this? Can I have plus 5? Think about this. All right, who says yes, I can have? Who says no? Okay, so those who participated, you are correct. So yes, I can have the same y-intercept in this case because it would just show that they cross at the y-intercept. Yeah.
And you have a negative.
Yeah. So you can have y equals negative 1/3 x minus 5. So remember parallel, you cannot have the same y-intercept. Perpendicular, you can have the same. Okay. Example. So far, everything right here that we did, this is actually nothing new. We did this last week. Okay, with parallel and perpendicular lines. So here is what we did yesterday, how it ties into yesterday's. Write the equation of a line that is parallel to y equals 3x plus 5 and goes through this point. So this part right here, parallel to y equals 3x plus 5, what can you imply out of it? Melissa? Slope stays the same, so m equals 3. And you're given a point. Alright, do you see how this is like yesterday's lesson now? Given the slope and a point, find the equation. Okay, so those of you who did your homework, which is the majority of you, what did we do? Khan, I know you did your homework. What did we do? You forgot. What do we have to do when you're given m and x and y? How do we find the equation? Let's see. Okay, Kaden? Yeah.
Can I give you the formula?
Sure.
Y minus y1.
Oh, okay.
X minus x.
Okay, you could do that, or Con, what were you gonna say? What we need to find the y-intercept, so we are gonna substitute those values into y equals mx plus b. Right, so your y is negative 6, your m is 3, your x is negative 2, right? And we try to solve for b. Right, so what does b equal? Let's see, Catherine. Negative 6 equals negative 6 plus b, so b equals 0. Yes, I think we all heard that. Alright, so now that we have m and we have b, let's let Catherine answer this one. What is my equation then, if I put it together?
Y equals 3x.
And that's it. Good. See, I know you got it. Alright, do we need to put that plus 0 right here? No. Okay, so some people did yesterday. Okay, so don't put that 0. Okay. Okay, so you see how this relates to what we did yesterday? So instead of just telling you my slope is 3, you had to figure that part out. Okay. Next part. Write the equation of a line that is perpendicular to this and with the same y-intercept. Okay, so looking at this, can you tell right off the bat what your slope is? No, yeah, so we have to do what we did last week. Rearrange equation. Who's good at rearranging equations? All of you guys are. Sarah, can you help me with rearranging? You're good at it. And and the 40?
Oh, and the 40 and then
right.
put like x is 0.
Oh, you're thinking x and y intercepts, but we're just rearranging the equation so that we can see what our slope is. All right, what do I do with that -5 now? Yeah. Excellent, divide it. Right, so what's -3 divided by -5? You get positive 3 over 5. And what is -40 divided by -5? Who's good at mental math? Eliza, I know your math is good. -40 divided by -5. Negative, 2 negative make a positive, right? So +8. Okay. So that means my slope of this line is 3 over 5. Is that the slope I want? No, I want the perpendicular slope. So let's see, Audrey. If my slope is 3 over 5, what's the perpendicular slope? -5 over 3. Perfect. Right? And it has the same y-intercept, so what is B? Sorry? Misha? 8. Yeah. So now that I know the M, I know the B. Zoe, can you give me the final answer? Y equal the mx plus b. So this is your m, this is your b. So replacing it in the equation. Okay.
Y equals to -5 over 3 x plus 8.
Right. Okay. Good. So all this right here is to rearrange it so that you figure out what your slope is, and then figure out the perpendicular slope, and then put it together. Okay. Any questions so far? Right. These questions does take practice, especially a question like this, which is like multi-step. So first you have to rearrange. Second, you have to figure out the slope. Third, you have to put it back together into an equation. All right. So the part that people find confusing is you're given an equation and you're actually finding the equation of the second line. Right? That's what you're trying to do. So for example, right here, like let's say I give you the equation of the blue line, you're trying to find the equation of the red line. Okay, so that's what the questions are asking. Okay, example 4. Okay, so this is a little trick. Okay, whenever you see a question that says parallel to the x-axis or perpendicular to the y-axis, these type of questions, you want to do a quick little sketch. A sketch is the best way to do these questions. Right? So right here, I have the point 2,5. And if I want a line that is parallel to the x-axis, parallel to this, am I looking for a horizontal or vertical line? A line that is parallel to the x-axis. Yep. Horizontal. So that's why it's a line, horizontal line that goes through this point. Okay, so what is the equation of this point? Is your hand up? No, you're stretching? Okay. Let's see. Eliana? Ooh, ooh, ooh. Horizontal line means there's no x. It just goes through the 5, so it's just y equals 5. Right? Horizontal line is just y equals the number. Whenever you have an x in there, it will mean that you get a diagonal line. Okay. Then what about this one? Write the equation of a line perpendicular to the x-axis. What type of line are we talking about then? Well, perpendicular to the x-axis. Right. Yeah. Which is, what do we call those lines? These are, if this is horizontal, that one is vertical. We're looking for a vertical line that goes through the point -4, -5. So right there, a vertical line that goes through the point -4, -5. What's the equation of these lines?
X equals to -4.
Yeah, that's it. Okay. So vertical and horizontal line, we also learned it last week. What's different this with today is we're using the terms parallel and perpendicular. Okay? And as I said, like notice these ones, I didn't have to solve for B, I didn't have to solve for M, I don't have to do anything algebraically. All I did was I did a quick 10-second sketch. Right? So whenever you see these questions, parallel or perpendicular to an axis, just draw the quick sketch. On the test, you can do that as part of showing your work. Okay. How are we doing? Okay, last example. So one last example right here. Example 6. Given these 3 points, show mathematically whether the points form a right triangle. All right. If you see this question on the test, all right, this question may be out of 3 or 4 marks. What's the key word right here? What's the keyword in this question to make it worth 3 or 4 marks? Mathematically, right? So if you draw me a sketch and I say, hey, this angle looked like 90 degrees, you're not going to get the mark. You have to show mathematically. That's why it's worth 3 or 4 marks. All right. So I did a quick little sketch right here with the 3 points. Okay. Now looking at angle A, angle B, and angle C, which one of those angles look like is the right angle? which one? A, B, or C? A, that's right. Okay. Now what does it mean by right angle? 90 degrees, that's right. But wait a minute, we're not in the geometry unit. We're doing geometry last. All right. Based on what we learned today, what is that implying? What does it imply we should do? 90 degree, yeah, perpendicular. And how do we tell that it's perpendicular? What do we compare? What do we compare? Melody? To tell that if it's perpendicular or not, we should the slopes, right? We have to compare the slopes, right? So why did I do a quick little sketch is I can tell this one looks like it's the one that I want to compare, okay? Otherwise, I would have to do the slope for each of these lines, but instead of that, I can just compare the slope of AB with the slope of AC. So I just have to compare the slope of these two lines. So slope of AB. Okay. And again, the keyword is mathematically. How do I find the slope mathematically? Given two coordinates. Yeah.
y2 minus y1 over x2 minus x1.
Excellent. Okay. Whenever I give you the coordinates of points, you want to use the formula. It's a minus, it's not a plus. It's y2 minus y1. If you make it your own formula, you are going to get the wrong answer. Okay, so substituting it in, so 0 minus 7 over negative 8 minus negative 4, you get negative 7 over negative 4, which is 7 over 4. Right? So the slope of this line right here is 7 over 4. Okay, can you guys take 30 seconds to find the slope of AC? Okay, take 30 seconds, find the slope of AC. And this is tricky. That's why I'm asking you guys to try it first. So slope of AC, same formula, sub in the numbers. So now you're using the coordinates of these two. Okay. Okay, so finding the slope should not take more than 30 seconds. Okay, I plugged in those numbers. Okay, and when I subtract it, I get this. Okay, how many of you got that? Negative 6 over 10.5. Good, okay, but do I like this answer? Why not? Fraction and decimals. Yeah, remember in the first lesson, chapter 1, I said decimals and fractions, they don't mix. They're like rivalries, and it looks so weird. Alright, so who has the big brain here? How can I change it to a fraction of integers? Yeah, Martin?
You multiply by 2.
Multiply the whole fraction by 2, and I get negative 12 over 21. Alright, do I like this answer? Okay, Ethan says still no. Why not?
You can still simplify it.
I can divide both top and bottom by 3 to get negative 4 over 7. Alright, and then now what do you realize? What connection do you see? Yeah? Negative reciprocal. Right, 7 over 4, negative 4 over 7. They are negative reciprocal slopes, which means angle A is in fact a right angle triangle. Angle A is a right angle, so which means that this is a right angle triangle. Adrina? So notice here I have negative 6 over 10.5, but I don't like decimals in a fraction. It's just weird. So what Martin suggested is I can multiply this whole fraction by 2. So negative 6 times 2 is negative 12. 10.5 times 2 is 21. Now it's a fraction of integers. And then I can actually reduce this fraction. Yeah, so this part from here to here to here, it is thinking beyond. So big brain. Okay. So on the test, will I do something like this to trick you? Oh, okay, you're giving me ideas. So I wasn't going to, but as long as you can see the connection because with negative reciprocal slopes, then I'm happy. Okay, this is thinking beyond. Okay, yeah.
Is it like okay to just divide it? Or do you have to like show that?
But you can't. Well, I guess you can divide this and this by 1.5 to get to here. But I just showed this step to this step because I think it's a little easier to see. Yeah. Okay, so as long as you can tell the connection between the negative reciprocal slopes, I'm happy already. All right, so let's do a quick little summary of today's lesson because we did go through quite a bit. So when the slope is the same, you get parallel lines. When the slopes are negative reciprocal of each other, you get perpendicular lines. What we did yesterday, given the slope and a coordinate and one coordinates, you can plug it in to figure out the equation. These type of graphs where it's parallel or perpendicular to an axis, you want to do a quick sketch to figure out the equation. That's the easiest way. These ones right here, it does take practice. Like once you do a couple more of these, then it's so much easier to understand. At the beginning, it could be confusing. So try the homework, you will see these come up. And then lastly, to find if it's a right angle, it implies that you're looking for the negative reciprocal slopes. So you're doing the slope formula to compare. And once you see it, then yes, they are reciprocals of each other. Okay, so that's the lesson for today. This is the homework. You have how much time? 25 minutes. Yeah, you have 25 minutes to try these questions right here. Today you guys did pretty well with the homework. Those two people, make sure you do it. Make sure you do these ones. When is the next assignment again? When is the next assignment? Monday, right? Okay, and it's going to be based on tomorrow's 7.2. Okay, thank you.